Hello and welcome everyone for today's webinar. My name is Stefan Giebele and today I'd like to show you how easy it is to send data between a S7 1500 and Microsoft Azure. Very important to mention one point, everyone who has registered will get a follow-up email containing a record of this webinar and the presentation as well. So the session today is separated in two parts. We will start with a theoretical part where I'm going to explain what MQTT is and how it works. In Chapter 3, I will give you a brief overview about the dataFEED OPC suite, the software which we are using today to send data to Azure. This is followed by the live demonstration. So what is MQTT? MQTT is short for Message Queuing Telemetry Transport and it's an application protocol. You have maybe heard of other protocols like OPC UA or HTTP. MQTT is simply another way of communication and it's lightweight, which means your devices which speak MQTT does not need lots of computing power or need much resources. Therefore, it's ideal for IoT devices like sensors, small devices, or even cars. It has a published subscriber architecture. I will explain what that is on the next slide. It's using TCP in the transport protocol, and a few words to security. Authentication can be done via username and password or user certificate, and of course data can also be encrypted by using an SSL connection. So how does MQTT work? I've just told that it has a published subscriber architecture, and this consists of three parts. On the right side we have a publisher, in the middle is the broker, and on the right side are the subscribers. So the broker in the middle is some kind of distributor or dispatcher, and on the left side we have the publisher, which actually generates or have the data and send the data to the broker. On the right side we have the subscribers, which are interested in that data or only specific data, and if they want to receive that data they can make a subscription and the broker will send the data to the subscribers as soon as they are available. Important to mention here is that the publisher and the subscriber never talks directly to each other. There must always be a broker in between. The publisher is the dataFEED OPC suite, the software which we are using today, is representing the publisher, and the broker and subscriber are located in the Azure cloud. The dataFEED OPC suite is a software from Softing, which you can install on your computer or on your server, and what it does is simply explained by looking at this picture. So we have the possibility to collect data from different data sources, like an OPC UA server or an OPC Classic server. We can also read data from a SQL database, and like today, of course, we can collect data from PLCs from different vendors, Siemens, Rockwell, Mitsubishi, also Schneider, Phoenix, everything is possible. Once we have done that, once we have collected data, we can decide to which destination, to which data destination we want to send that data or we want to provide that data. So for example, we can grab data from an OPC UA server and do a conversion and provide this data as OPC Classic. Or we can grab data from a controller, from a PLC, and rewrite that data into a SQL database or a NoSQL database. So we have quite a few possibilities what you can do with dataFEED OPC Suite. What we are doing today is simply described. So in the first step, we will establish a connection between dataFEED OPC Suite and the S7-1500. This is followed by the establishing of the connection between the MQTT side, so between dataFEED OPC Suite and the Microsoft Azure. And in the last step, the third step, we have to decide which data we want to send, so we have to do a mapping. This is already the end of the theoretical part. I will now start with the live demonstration. So what I have to do first is I have to start the dataFEED OPC Suite. And now again, I explain that again, I have the possibilities to collect data from different sources in the data source section. So possible is to collect data from a Rockwell, PLC, Modbus, B&R, Mitsubishi, can collect data from OPC UA or OPC Classic. But in today's session, I want to establish a connection between dataFEED OPC Suite and the Siemens S7-1500. So what I have to do is I add a new data source by clicking that button here. I can give it a fancy name, let's say Siemens 1500. On the next step, I have to decide which application protocol I'm using. Since I have a S7-1500, I'm using this protocol S7-2, which allows me browsing, and I have also access to the optimized data blocks. I proceed here, and what I have to do is to type in the IP address of my PLC. I'm doing a connection test, and it says successful. I proceed. I can activate here some filters, but it's not necessary because it's a demo. And now you can see I can browse all the variables which are provided by the Siemens. I don't have to do a symbol import, and as already mentioned, I can access also the optimized data blocks. So the first step is done. I have established a connection between dataFEED OPC Suite and my Siemens PLC. So I press finish. The next step is the actual configuration of the cloud. So if you log in to Microsoft Azure, this is the landing page. And the service which we are using today, or the service which receives the data from the suite, is called IoT Hub. So the IoT Hub is one service that is provided by Azure, and it's used for receiving data from underlying devices like the OPC dataFEED suite. So I press here IoT, and it already says here's IoT Hub. So I click on it. I have already created here some IoT hubs. It's possible to create your own. Simply click on Add, type in a name, and that's it. So I proceed here, and I'm using Softing IoT Hub Sales Demo. So very important, this is the host name, and I need this in a later step, so I copy that and paste it into a text file. You get here an overview about your IoT Hub. You can do some advanced settings, some security settings. I don't do that, I don't show that in this webinar, so I just want to send data to it, and this is done by the section Explorers IoT Devices. So I click on it, and now I can see all my previous created devices. So for instance, this is a digital representation of your physical device. So you can add here a temperature sensor, humidity sensor, PLC, whatever. So I want to start from scratch, so I add a new device here, and I call it PLC Siemens. That's pretty much everything what I need to do on Azure. I just click Save, and now it appears here. So this is everything what I need to do here. So I can start now. I go back to my dataFEED OPC suite. I have already established or defined a data source, but now I have to decide to which destination I want to send that data. So I go to the section Data Destination, and it provides me here a lot of options. I can provide the data via OPC UA or OPC Classic. I can write the data into a SQL database or into a file. But in today's session, I want to send data to an MQTT broker, so I'm choosing data destination MQTT broker. I click on Add, and I can again specify a name. Let's call it MQTT Azure. I have to specify here my client ID, and the client ID is the name of my device which I have created. In my case, it was PLC Siemens. I proceed here, and I want to send data in the encrypted way, so I'm using SSL. So what is my address? I have just said in the beginning that the host address can be found on the overview side, and this is actually my URI. It's the name of the IoT hub, .azure-devices.net. The port which I'm using is 8883 because I'm using the SSL. Now I have to specify the authentication settings. In my case, it's username and password. So the username is defined in this format. So every device which want to connect to Azure has to follow this. It starts with the name of your IT hub / client ID. So in my case, it's that one here, and my client ID, I switch quickly back, is Siemens PLC. Let's see it again. / So I copied it and pasted here. Now I need a password, and this is actually, I wouldn't say problem, but you haven't seen me creating a password. And this can't, unfortunately, it can't be done in Azure directly. So I need an additional tool for it. This tool is called Device Explorer. I'll show you that in a minute. So this tool is only used for creating the passwords. This is a tool not from Softing. It comes directly from Microsoft. You can download it via the GitHub page or type in Device Explorer into Google, then you will find the download. It is possible to go other ways, but this is the recommended way by Microsoft to use that way. What I have to do is I have to establish a connection first between the Device Explorer, between that software and my IoT Hub. And this is done by entering the so-called IoT Hub connection string. I show you where you can find it. So I go back to Azure and I go here under Settings, Shared Access Policies, IoT Hub Owner, and the string here, the connection string primary key, it's the one to use. So I copied it and paste it here in. And what I only have to do is press the update. Okay. So I now go to section Management, and there it shows me all the devices which has been created under this IoT Hub. I click on My Device and press SAS token, which represents the password. I have to specify here again the device, PLC Siemens, and I have to enter the time to live, how long my password should be valid. I'm using 1 year, press Generate, and the part after shared access signature equals, that is the password. So once again, of course, other ways are possible to generate a password, but this is the easiest way by far and the recommended way by Azure. So I've already typed my password in, and now I'm doing a connection test. And it says connection test successfully. I can proceed with the next step, and now I have to specify the so-called topics, which represents my data which I want to send. And this has to be in a specific format as well. This is also given by Azure. You can read that in the documentation of the IoT Hub. It has nothing to do with softing. So I start with a node called Devices. Then I have to add another node which is representing my device ID. In my case, it was PLC Siemens, if I remember correctly. Then I have to add another node, which is called Messages. This is followed by another node, Events. And the last step is that I have to create my text, which represents the actual data. In my case, I want to send a temperature value, so I call it temperature. So this is the hierarchical structure which I need to use to send data. I have to be very careful with the spelling. If I made here some mistakes, I'm not able to send data to Azure. So the first devices, this is static, you can't change them. The second one, PLC Siemens, represents my device ID. Messages and events are also static. This is given from Azure. I can't change that. And the last bit specifies the data which I want to send. So I've done everything here, so I can proceed to the next step. Last will and testament. I can specify if I want to send a message at the beginning, and if the dataFEED suite would disconnect ungracefully, then Azure Cloud would send this last will message to the underlying subscribers, like a disconnect message. Okay, I could specify the message here, but I don't need it. It's optional. Yeah, store and forward is also possible. Yeah, I think I don't have to say anything about store and forward. So what it simply does is it stores my data, and until the connection is reestablished, it forwards all the messages. So everything done. Second step is done, the establishing the connection between dataFEED OPC Suite and Azure. So the last step what I have to do is I have to do the mapping. So I haven't decided yet which data I want to send. And this is done in the data processing section of the dataFEED suite, which you can find here. I go to Exchange and activate it, and now I have to select my source. My source is Siemens S7 1500, and I've got already provided here a room temperature sensor, and I want to send that to Azure, which is here. I press the button in the middle, and now I've created here that exchange. I have to specify when the data is being sent, so it could be item, which means on change on value or change on quality. You could also specify timer, which I'm doing today, or variable driver, which means if the temperature is greater than 25 degrees, it will send the data. I'm using timer, and I have to follow this wizard again. I want to create a new trigger. Let's call it timer 1 second. So I want to send every second a message. Next, interval timer, 1000 milliseconds, which is 1 second. And I press finish. The last step what I have to do is start the dataFEED OPC suite. So if I've done everything correctly, data should now be received by the IoT hub. Unfortunately, I can't see the data directly. I can see that data is received, but not the actual content of the messages. And that's why I'm using again the Device Explorer. I go here to Data, and I can monitor the devices. And now you can see it's receiving data. I can now try to heat the temperature sensor a little bit up, and as you can see, the temperature is increasing. Okay, this is already the end of the practical part. Now it would be time, if you have any questions, you can ask. I can see that we have no questions. Okay, that's fine. Additionally, you can send me an email at every time, and I try to give you a fast response. At this point, I'd like to say thank you. Thank you for your time. Once again, everyone who has registered will get a follow-up email containing the record of this webinar and also the presentation. In addition, I've just forgotten it, if you want to test the dataFEED OPC suite, you can download it on our website page, which you can see here, dataintelligence.softing.com. It has a free trial version for 72 hours. Thank you for your attention. Keep care and goodbye.